In this video, we will be working with vectors. We'll be sketching them in standard position, finding the magnitude and direction, and writing the vectors as a sum of unit vectors. So first, we are supposed to sketch vector D in standard form or standard position. And vector D is 8, -1. Standard position is all about starting from the origin, so that means we are going to need an x and y axis. So that's going to be my first order of business, will be to draw an x and y axis. So just give me a second to do that. Alright, so this will be my x-axis. I think I'll make it purple. This will be my x-axis, and here comes the y-axis. Okay, now we can draw the vector in standard position. So if D is 8, -1, that means it should be to the right 8 and then down 1. So that's going to look like this. 1, 2, 3, 4, 5, 6, 7, 8, and then down 1. Okay, so there it is. There is vector D. Okay, now we're supposed to find the magnitude of vector D, and the magnitude is going to be the square root of 8 squared plus -1 squared. So that's going to be the square root of 64 plus 1, so that's going to be the square root of 65. Now we need to find the direction of D. Now, be careful. The direction of D is the angle measured from the positive x-axis counterclockwise. So what I just drew there, and I'll call it theta, this is the direction. That angle is the direction. Alright, now in order to find that angle, what I actually have to start with is the reference angle, which I will call R. Now, looking at the components, this is 1 and this is 8. Looking at sort of the triangle that's formed here, what we know is the tangent of R, the tangent of the reference angle, is going to be 1/8. So therefore, R is going to equal the inverse tangent of 1/8. I'm just going to put that in my calculator. So I need to do the inverse tangent of 1/8. 7.13 degrees. Okay, so R is equal to 7.13 degrees. So that means theta is going to be 360 degrees minus R. So theta is going to equal 360 degrees. It almost goes all the way around, but it stops short by the amount R degrees. So the direction is 352.87. Alright, so now we need to write D as a sum of unit vectors. So remember that vector D in component form was 8, -1. So as a sum of unit vectors, that would be 8i minus 1j. And of course I won't put the 1, I'll just say 8i minus j. So that's how you write it as the sum of unit vectors. That's a very simple concept. Alright, so that's it for problem number 1. Let's slide over and do problem number 2. Now this problem is about vector b, so I need to look and see what vector b is. Vector b is negative 2 comma 6. So let me just write this down so I won't forget. Negative 2 comma 6. So again, if I want a standard form, I'm going to need an x and y axis. Okay, so there's my x and y axis. Now, vector b, the negative 2 comma 6 means left 2 up 6. So standard position means start from the origin. So left 2, that's up 3, 4, 5, 6 would be here. Okay, so there is my vector b in standard form. Now the magnitude. So since vector b is negative 2 comma 6, the magnitude is going to be negative 2 squared plus 6 squared. So that's going to be the square root of 4 plus 36. So that's going to be the square root of 40. Now 40, of course, is 4 times 10. 4 being a perfect square. The square root of 4 is 2. So we're left with 2 root 10. So this is the magnitude. Now the direction. So the direction of this vector is the angle as measured counterclockwise from the positive x-axis. So this is the angle that we are looking for. However, we will start by finding the reference angle, okay, which is sitting right here. I will call it R. And remembering that this has a length of 2 and this has a length of 6. So the tangent of R is 6 over 2. So if I want to find the direction, I can say the tangent of R is equal to 6 over 2. In other words, the tangent of R is 3. So therefore, R will equal the inverse tangent of 3. Okay, so let's take a peek at the old calculator and see what it says. Inverse tangent of 3. That is 71.57. So R is 71.57 degrees. That is the reference angle. Alright? Now, how does that relate to the actual angle theta, the direction that we're looking for? Well, theta should be 180 degrees minus this reference angle. Okay, so theta should equal 180 degrees minus 71.57 degrees. That gives me 108.43 degrees for the direction of vector b. Now let's write vector b as the sum of unit vectors. First, let's remember that vector b was negative 2 comma 6. Okay, that's component form. So as a sum of unit vectors, this would simply be negative 2 times the unit vector I plus 6 times the unit vector j. These little hats mean unit vector. It's just that easy. Okay, so it looks like that's it for number 2. For number 3, we are supposed to sketch vector A plus vector C, showing our method clearly. And look, here's vector A and here's vector C. Let's start with vector A, 3, 7. I can start anywhere. It doesn't need to be in standard position. I'm not even going to draw the x and y axis. So I'm just going to pick a point like this one. This will be my initial point for vector A. Because of the 3, 7, this means I will go right 3 and up 7 from here. So if I go right 3 and then up 1, 2, 3, 4, 5, 6, 7, this will be my terminal point. So now I will go ahead and draw vector A from the initial point to the terminal point. Okay, so there's vector A. Now, vector C. Since we're adding, when you add, you want to place the vectors head to tail. So I'm going to start vector C at the terminal point of vector A. So I'm going to start vector C right here. The -5 and the -10 mean that I will go left 5 and down 10. So left 5, so 1, 2, 3, 4, 5, down 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this will be the terminal point of C. So now I will draw vector C from the initial point to the terminal point. Okay, now the resultant vector, the sum, should be drawn from the initial point of the first vector to the terminal point of the last vector. Okay, so my resultant vector should be drawn from this point to this point. Okay, so that green vector is my resultant vector. I'm just going to pause the video and label this. So this is what your sketch should look like for a problem like number 3. Okay, so now we need to write A plus C in component form. So I can look at the graph and see what it should be. Starting from the initial point, it goes left 2 and down 3. So that means the component form should be -2, -3. Now also, remember that we had the coordinates 3, 7 plus -5, -10. So let me just write that down again. So we didn't need the graph to find this, but let's just make sure everything is consistent. If I add the corresponding components, 3 plus -5, that's -2. 7 plus -10, that's -3. So it works out both ways. For number 4, we are going to sketch B minus C. And here's vector B and here's vector C. So first, vector B, -2, 6. We can start anywhere we want, so I'm just going to pick a point about here. I'm just going to pick, I'm semi-randomly picking this point. So my first vector b is -2, 6. That means if this is the initial point, I'm going to go left 2 and up 6. So this should be my terminal point. So now I'm going to go ahead and draw vector b from that initial point to that terminal point. And I'm going to let this one be blue. Okay, so there's vector b. Now I'm going to draw vector c. Now when I'm adding, I draw the vectors head to tail. I put the next vector, I start it where the last vector ended. When I'm subtracting, I put the vectors tail to tail. At least using the method that I'm going to use, you put the vectors tail to tail. There is another method. So I'm going to use the same initial point for vector c. -5, -10 means I will go left 5 and down 10. So my terminal point will be right here. So now I will go ahead and draw the vector from that initial point to the terminal point. I want this vector to be red. Okay. Now, when you are subtracting, you have to be very careful. So the way that you draw the resultant vector is you draw the resultant vector from terminal point to terminal point, across like this. But the order is really, really important. So if you want to subtract vector b minus vector c, when you draw, you must actually draw from vector c to vector b. So the order is reversed. I went ahead and labeled them now to make it more clear. So I'm going to draw my resultant vector from c to b. And that's terminal point to terminal point. And I like my resultant vectors to be green. Okay, so this is the resultant vector b minus c. Next, we're supposed to find b minus c in component form. Now, here is vector b minus vector c in component form. All we have to really do is subtract the corresponding components. So, if I do -2 minus -5, first of all, understand that that's the same thing as -2 plus 5, right? Minus a negative is addition. Similarly, if I do the other components, the vertical components, then this would be 6 plus 10. 6 minus -10 is 6 plus 10. So that's what I'm doing. So that's why I'm going to get 3, 16. Alright, so this should be the vector b minus c in component form. Now let's compare that to what we got graphically. According to this, the vector should go to the right 3 and then up 16 from its initial point. So does that look about right? Okay, from its initial point, if I go right 3 and up 16, kabam! Nailed it. For number 5, we are to sketch d plus a, clearly showing our method. I'm going to start with vector d, 8, -1. We can put it anywhere. It doesn't have to be in standard position. So I'm going to start vector d here. This will be my initial point. So according to the components, I should go right 8 and down 1. So let's see, 2, 4, 6, 8, and down 1. There's my terminal point. Let's draw. So this should be vector D. I'm going to make it blue. Okay. Let's see, can I fix this a little bit? Now, let's do vector A. When you are adding, you put the vectors head to tail. So that means we will start vector A from the terminal point of vector D. So this will now be the initial point for vector A. From there, we should go right 3, up 7. So right 3 and up 2, 4, 6, 7. There's my terminal point. Alright, so drawing vector A, it's going to look like this. I'll make this one red. Alright, now for vector addition, the resultant vector should go from the initial point of the first vector to the terminal point of the second vector. So from the overall beginning to the overall end. And I like my resultant vectors to be green. Always be sure to label everything clearly. So let's see, now we are supposed to find D plus A in component form. Let's see, D plus A. So let's just add the corresponding components. So 8 plus 3 is 11, and negative 1 plus 7 is 6. Alright, let's compare that to what we got graphically. So the resultant vector should be going right 11 and up 6. Let's check it out. So from the initial point, if we go right 11 and up 6, it matches perfectly. For number 6, the numbers get pretty big, so I had to use graph paper with smaller squares. Thinking ahead a little bit, it seems like I'm going to have to start on the right hand side and up pretty high to leave myself space to do this graph. So I'm going to start right about here. Alright, I'll let this be my initial point. So I'm graphing the vector 2c, which means I'm going to really just start by graphing vector c. Negative 5, negative 10. That means from the initial point I will go left 5 and down 10. So I'm just going to count very carefully. Okay, so this is my initial point, and my terminal point would be here. So that is vector c, but I'm supposed to do 2c. So I'm going to do that again. I'm again going to go left 5 and down 10. That way, instead of just having c, I will have done 2c. So here's the terminal point of my second vector c. So now let's go ahead and draw 2c. So the vector 2c should go from here to here. Okay, this is the vector 2c. And I want it to be blue. Alright, now it's time to draw the vector b. When I'm subtracting, I put my vectors end to end. So my initial point for vector b is going to be the same point I used for my initial point for vector 2c. So I'm going to start from here. Now vector b, negative 2, 6, means left 2, up 6. So I'm just going to count over left 2 and up 2, 4, 6. So this will be my terminal point of vector B. Alright, so I'll just go ahead and draw vector B like this and make it red. Alright, so this is vector B. Now, whenever I am subtracting, sure, I put the vectors that I want to subtract tail to tail like this. But the difference, the resultant vector, will go from terminal point to terminal point across like this. But the order you have to be very careful with. If I want to subtract vector 2c minus vector b, when I draw, I must draw from vector b to vector 2c. In other words, I must reverse the order when I draw my resultant vector. So that's why I'm going to draw from vector b to vector 2c like this, from terminal point to terminal point. And let's make it green. Okay, so this is the vector this is the vector 2c minus b. Make sure you label everything as you go like I just did. Alright, now we need to find this in component form. So now we have to find 2c minus b, and I've written the component form here for the problem. Multiplying by 2 gives us negative 10 comma negative 20, and minus negative 2 comma 6. Now all we have to do is subtract the corresponding components. So negative 10 minus negative 2, listen, that's the same thing as negative 10 plus 2. You know, minus and negative is addition. And then we have negative 20 minus 6. So the final answer will be negative 8 comma negative 26. Alright, how does that compare with what we got graphically? Let's look and see, does the resultant vector that we drew go left 8 and down 26 from the initial point? So I'm not going to sit here and count, but it looks about right. Left 8 and down 26. That's why I had to stitch together two pieces of graph paper. For number 7, we are to sketch vector 2b. We can start anywhere, so I'm just going to pick this spot for my initial point. Just kidding, I'm going to pick this spot for my initial point. So I'm going to graph a single vector b, and then I'll graph another vector b, and then I will have 2b. So negative 2 comma 6 means left 2 and up 6. So 2, 4, 6. So if I drew a vector from here to here, that would be vector b. But we want 2b, so I need to do that again. So again, I'm going to go left 2 and up 6. 2, 4, 6. Alright, so for vector 2b, this will be my initial point and this will be my terminal point. And I can just go ahead and draw that guy. Alright, and I'll just make it blue, because why not? It's pretty. So this is vector 2b. Now, we are supposed to find 2b in component form. So we'll just multiply and we will get -4, 12. Which is clearly what we have here if I went left 4 and up 12. There you go. Now for number 8, we need to sketch -1/2 of vector C, which is -5, -10. Now, if I graphed a single vector C, I would go left 5 and I would go down 10. So 2, 4, 6, 8, 10. This would be a whole vector C. Okay, so this would be vector C. And I'm going to go ahead and let it be blue for now. Alright, this is what vector C would look like. So I need to do two things. I need it to be negative, which means I need to reverse the direction of it, and I need it to be half as long. So for starters, let's reverse the direction of it. Now if I want to, I can use what I have and I can rotate it 180 degrees. Alright, that's way I just don't have to redraw it. Alright, so now it's going the other way. So because I reversed it, I'm going to change the color to purple. That just reminds me that it's -C now. So at this moment, what I have drawn here is the vector -C. Alright, the whole thing is -C. So now I want a vector that's half of this. So let's see about where the middle point would be. Well, we know that it has a height of 10. So let's count up 5 and that will help us see where the halfway point is. Alright, so from the bottom here, if I go up 1, 2, 3, 4, 5, so this should be the middle point, alright, because it's halfway up. So this is the middle point. So if I draw this vector, that will be -1/2 C. Alright, it's half of -C. That's -1/2 C. Okay, so I'm just going to draw this new vector, but this time I'm only going to draw it halfway. And I'm going to make it green. I'm going to make it extra big since it's sort of overlapping. Okay, so this vector right here is my final answer of -1/2 vector C. Okay, now in component form, I'm just doing the distributive property. Negative times a negative is a positive, so that's just going to be +5/2. Right? You can think of this as 5/1, and I'm just multiplying straight across. Negative times negative is a positive. Half of 10 is 5, so I will have +5. So this would be my answer in component form. Alright guys, that's going to be the end of this video. In my next video, I'm going to show you how to work with vectors that do not have graph paper behind them. So I will show you how to add, subtract, and multiply vectors without any kind of graph paper or coordinates. See you on the next video.